Luca Dei Zotti. Please, yeah. Thank you. Our next speaker is Luca Dei Zotti, following up from José's incredible keynote, Luca will be exploring a very interesting problem. How do you debug a live system when you have fairly limited access to it? So yeah, José showed the great power that Livebook has. And yeah, Luca will be showing a concrete example of how to debug a system when you have limited access. So luckily the Beam has some great capabilities around tracing, and you can basically hook into the message passing of anything you want. And yeah, Luca will be teaching us about that with a concrete example. So yeah, let's all welcome Luca to the stage.
Hello, everyone. Thank you for being here today. Pretty excited to be sharing the stage with people I usually follow on Twitter, so please be patient with me. Not here to teach anything to anyone today. So, who I am? I am Luca. I am an engineering manager for Prima Assicurazioni, which is an insurance company that is also the sponsor for my travel today, so please show some love if you can. The problem I want to explore is pretty simple, and it is our problem. I'm still a software developer. And it is that the world is complex, that software development is a hard discipline, and we don't help very much making things simpler, usually. So we just write our software, and we pack in some way, and we usually end up in a couple of situations, like we deploy our software on some premises, we choose Fly.io or Heroku, and we deploy it as a SaaS, or we enter the microservices hell and Kubernetes and whatever. And all those kind of deployments have something in common. I'm not addressing something like a desktop application today. And the thing that they have in common, we will see later. What happens then? We deploy our software, and usually if we have been good developers, we instrumented observability, we choose some service, around 1,000 out there, just to see what is happening into our infrastructure, not related to any of those services, of course. Through observability, we just gain a lot of insight into what is happening into our system. Most of our libraries, the tools, are already instrumented. They support OpenTelemetry or whatever we prefer. But what is not covered is that we are the ones who write the core business logic. And we, or at least I, make mistakes. We forget, we didn't think it was important to instrument observability at that certain point. Our super senior colleague said, no, don't use Phoenix because it's bloated, just use this library, whatever. Or someone said, no, you have to use this library that has not observability included. Or we simply tried and got it wrong. That is probably the most common. Now, in almost all the technology stacks, we are pretty lost in the dark. We can take a look at the logs, we can watch a core dump or whatever. But in our case, we had something in common, and it is that our nodes are reachable, hopefully, if our plateaus operations, security operations allows, of course. And then we can see what OTP gives us to rescue us. Now, this is not a talk about LM distribution, so there are a couple of slides here that I will jump right away. You can take a look later if you are interested. But what is interesting about the Erlang and Beam distribution, in this case, is that I say that the nodes connect between themselves. Wow. They are reachable. They have a name that we can resolve in some way through our system. And when we connect to a node that is part of a cluster, we connect to the entire cluster. And it's a pretty interesting thing to know. Now, there are some slides that I will just jump. Forgive me. See them later. This is not a talk about distributed system at all. But let's remember when addressing this kind of situations that we are in a distributed system. So bandwidth is not infinite, big messages, latency exists, don't expect your messages to come and be in a certain time. Network can fail, is insecure, we have the cap theorem and all the variations that have been born through the years. I wanted to jump just to the demo because I like it. So I prepared a simple application that we will totally forget it is a Phoenix application, okay? It is just a generic web application with a couple of REST endpoints. It is up with a Docker Compose, but again, just to avoid the networking problems today, sorry for that. Let's suppose it is in production, so we have just a channel available to reach it. Okay, we have two names. They are Ratchet at Ratchet 0 and Ratchet at Ratchet 1. Let's jump directly to the live book. The things should be running on my notebook now. Sorry, I also thought I would have had a mouse, so some interaction may be clunky from my side. Sorry for that. Okay, as you can see, we are in our live book. We have some dependencies installed with Mix. Some of the usual ones, and some that I just decided I wanted to. No, of course, this is not working like I wanted to. Okay. A disclaimer of the whole experience is, of course, that the things I will show can probably be done in a couple of other ways, probably better ways. Some of them could have been done just using a remote shell and jumping into the application. And also, I'm not using the Phoenix ability to, the Livebook ability to just connect to our application because I didn't want to enter the context of the application. I wanted to use Mix, for example, in this case, and I wouldn't be able to do if this was the case. I don't know why this is not working as expected. So a basic gotcha of the whole experience is that the host part of the short name that we are using must be resolved through the system name resolution. So just check with my machine that we had the IP addresses of our instances. Of course, this becomes a networking problem respect to our company infrastructure. Okay, we just care that the application is reachable. Now, just check that I spin up the Docker instances, which I did. Wow, good. Let's just, this is the setup phase, please be patient. Let's set up some configuration, like the node that we will use as a main target for the experience, the node that we know about, the cookie that is, let's remember, a mechanism for separating nodes on the same machine. It is not a security mechanism, so let's remember this. From the networking side, and the endpoint that we will reach the most. Let's see if the shortcut works now. Okay, thank you. So a basic way to connect to a remote node from a shell or a live book is using the function that we had from OTP, Erlang, and Elixir. We have a set of functions that are really sparse in some modules in the Erlang way. So we have netkernel connect, node connect from Elixir, netadmin ping that answers us with a pong, and we see that our application is reachable. Now we can just use the ARPC module to execute remote calls to our target node, just like Jose showed before. So we see that we have the node self of the current node, that is livebook something, and we can execute the same operation on the remote node, so getting our ratchet at ratchet 0 result. Let's, again, let's prepare a small utility just to wrap up some APIs without too much bloat, not important the code here. We have our server up, we have a way to reach them through a REST API. Let's see, okay, we have an answer from our node. We see that the node knows himself, he knows Ratchet1 that is his twin, and he knows the livebook instance that just connected to him. Let's enter the real debugging moment. So we suspect, in the situation of course, that there is an endpoint that is causing some troubles in our application. So people are reaching out to the API Fibonacci endpoint, but they seem to wait too much for their result, and they're paying for it. So let's see, okay, normal call, normal time. Let's try with a greater number, and we see that we start waiting way too much. So 5 seconds, way too much for a Fibonacci number that isn't arriving. We have to understand what is going on. The first friend that we will have in this experience is DBG from the batteries included with the beam, and it is maybe the second most basic tool in the set that is given to us. It uses LM trace under the hood, which we will not use today. And let's do a little disclaimer. Let's remember, tracing nodes is not easy. because when you trace too many things, you will make your node clunky. If you trace a function that is used by your tracer, you will have a deadlock. And of course, you have to know a little about your system, because deciding what to trace is a science driven by anger, coffee, tea, tears, whatever you prefer. A typical DBG session usually looks like a setup phase, where you just start the stuff, a configuration phase, where you decide what you want to trace, you let the application make some noise, or you just poke it a little, and then you read the result. So, in our case, let's pretend we remember a recent ticket on substituting an old clunky old Fibonacci function with a brand new tail Fibonacci one. But we don't know if it has been merged, shipped, or whatever. So let's see. First of all, let's stop any DBG process in the remote machine. The leader self-promotion time, while playing with this, I just created this smart cell to learn creating smart cells. It just does these things, or connecting through a node through normal distribution and executing a simple command. We will not use it a lot today because it's pretty graphically intensive. So let's start DBG on the remote node. I hope you see the comment where there is the actual command that is executed. Now, we started DBG. We will start what is called a trace port for handling trace messaging without passing from the beam messaging. So it's a really low profile. Not free, but still low profile. Also, the port will be created on the remote node, because we cannot trace a remote PID on a local node and vice versa, so we just wrap everything in our AIPC cores. The result is a function that returns a port that is suitable to be passed to DBG tracer. That is another function that we will use. Please go here, okay. A little note on the port configuration, sorry for that. We passed a single file name as a parameter here, the traces one, but we could have used a more complex configuration, like a maximum number of files, maximum size, maximum time for a file to be opened, a wraparound configuration, so pretty complete configuration. Let's remember that tracing is not free also space-wise, okay? So let's start the tracer on the remote node using DBG tracer. We see that we have an OK on the node that the thing has been executed to. And now we are almost ready to start tracing. We will use dbg.p, pretty expansive name like Erlang, like always. P stands for process. And we are just saying, OK, let's trace multiple processes or port, and let's do a little initial filtering to the messages received and sent. In this case, we are, of course, tracing everything because we can, and, but only the cores, not the messages, so just a little of forgiveness from my side. Let's evaluate it. I don't know, it is jumping. We see we are matching on 288 processes here. So now we can check if our alleged function, old Fibonacci, is called. Let's create what is called a trace pattern. A trace pattern is a set of module function arity and a match specification that, for the one who may not know it, is like a regular expression for Erlang code. And this will enable DBG to understand what to narrow down in the trace. So in this case, we will just match the module ratchet math Fibonacci, the function old Fibonacci with arity1, and we will use a catch-all match specification just for cheating a bit. We also have, of course, a couple of built-in match specifications from Erlang, which we will not use today, but it's nice to know that they exist. Done. Now we are set up for this first round of debug. Let's generate some noise. Of course, in production, be cautious because there may be destructive APIs. You may have to wait for the tracer to receive something. Let's now see what it is inside our remote traces file, and we will see that we have some binary content. Honestly, we could have just do a cut on this file and see some function calls, but for the sake of completeness, let's create now what is called a tracer client. It is a process along with a handler function that takes messages from a port and interprets them. In this case, it is super easy. It is like just does a file write on a traces translated file with, oh, I called this, okay? Nothing fancy, but we have an error. It is a wanted error. Why? Because we just created a local function and tried to send it to a remote node, and it has not been really super friendly for him. We can achieve a similar result. It's horrible to witness, but you can do it using a code eval string from Elixir, or the equivalent from Erlang, just by wrapping up your code in a string and send it to the remote node. Okay, so we are evaluating eval string on the remote node, and we now have our handler function for the port. Of course, we have other ports available with Erlang, like an IP port that sends the traces to an IP address. But in our production environment, it may be difficult to just open another port, another IP, so I just went to the file option in this case. Now we should have a traces translated file, which we have with our calls to the alleged function. Okay, nice first step. We have our alleged function. Let's stop the tracing, so we remember that it is low profile but not free, and let's do a step back. We did a lot of stuff for a super simple use case, right? And we didn't benefit from Livebook as greatly as promised. If we forget, of course, the stuff that Jose already talked about this morning. So we have a versional, configurable, a collaborative playbook, a nice UI, UX that is more reachable to the users. We had Mix to use some dependencies, and we had, if we wanted, some boilerplate smart sets. We could already have get something more, like in this case, I'm just trying all the APIs until I reach a 2 seconds timeout, and I can just plot something that makes me visually see where the problem starts to be, because I not only want the fading number, I want to see the exponential way for things to go. The Beam comes with a fully integrated suite of tracing tools with different aims. We will see just one if I had time today. But let's do a step aside this time, and let's try to solve the problem. Why? Because I know it is a super bad practice. Don't do it, but sometimes you just have to solve stuff before your CD, deploy pipelines touch production, or maybe you don't have continuous deployment or whatever. You just need your software to work because your business is at risk or lives are at risk, so whatever. Let's see how we can solve the problem in production. Now, we have found the guilty function. We have the module, which is luckily a pure module, so we have to do a little less steps to solve the problem. And this is the guilty module. We see that we have a call to the all Fibonacci function. So let's just copy-paste it to our Livebook and evaluate it. You see that we have this tail Fibonacci, that is the right function that I want to have in production. We have some binary code here. We could have removed the old Fibonacci function, but we don't know if it is dynamically called somewhere, so let's just keep it, don't play with fire. As you can see, we have the binary of the module, we have a connection. We understood that we can load live code on the remote node. So let's use again our ARPC call and use code load binary to load the binary of the module on the application. This path is ignored in the load binary, but it's still needed. Let's see. And now the function is really fast and has the correct result. Yeah, otherwise it would have been really awkward at this point. Unluckily, what happens if we start the application, this fix will be lost. In this case, although it is not optimized, you could just write the binary module, the binary code of the module on the right path, and you would have persisted the fix. We don't need it at the moment. There should be also another way, but I don't know it yet. We don't need now the fix to be in production, so we just restart the application, and we should see that the code, okay, it is still slow now, and it's what we were expecting. So let's see another scenario. We saw a simple one before of this one, right? But what if our function was the result of more function calls, okay? So we could have just this endpoint, this number info, that gives us more information like a factorial, a Fibonacci number, a square root, and any other information. In those cases where the result could have been the result of API calls or function calls or whatever, I find really useful to use flame graphs that are just graphs that allows us to see the execution span of a function from both a vertical perspective, like the function calls that compose our span, and the horizontal perspective of the time that each of those functions takes. So we'll just drop to a useful library by Status 3D that is called eFlambe, both from Erlang and Elixir, to generate traces that can be rendered as a flame graph. But we don't have it in production, right? We have installed it using mix install, but we don't have it in production. But we have a connection, we have a library, and you already guessed it, we are going to load it. The first time I had to perform this, I just did it manually, so just load a module, doesn't work, load another module, doesn't work. But then I read the documentation, yeah, and I discovered that there is this application get key that gives me all the modules of the application, so let's just reduce them enough for comprehension and load them on the remote node using, again, code library. All we need to know now, similar to DBG, is to start the eFlambe application and try to apply our function. In a real case scenario, equally to what we did with DBG, we could have just captured our execution flow and waited some time. In this case, we are just applying a function. Two little gotchas here. I had to explicitly enable the XML application in the Phoenix application because I wanted an SVG and not a brand and format, and also because I wanted an SVG for this talk and not making too much code, I used a modified fork of eFlambe that embeds a non-code asset like an SVG header. In this case, you see we're just doing an eFlambe app start, and then we apply our function ratchet get number info with 11. So again, some little knowledge about our code, our system in this case. This is the supervisor terminating. You see that we have an SVG, an XML content. So when I started imagining this talk, I had in mind writing a smart cell, looting other visualizers, just to show the flame graphs in this live book. But then SpawnFest 2022 happened, and Status 3D again made eFlambe live, so it allowed me to do this talk because I wouldn't never been able to write really that smart cell. And we can see that we have our flame graphs embedded in Livebook. Here we can see we start from the apply, of course, in a just a capture way. It wouldn't have started from here. We see that our get number info is called. We see a pretty fast square root, a less fast but still decently fast Fibonacci factorial with its own reductions, and then a super long guilty Fibonacci function. So again, you see that here we have the function name here, all Fibonacci, on the bottom of the graph, and we can see that it has been called. That's maybe for a more interesting use case, and we saw how we could trace live our node. So we have also a bonus track that I gained by jumping the previous slides, and it is tracing with sequential tracing. What is sequential tracing? It is the act of following a sequence of information, just like Jose showed before in his keynote. How does sequential tracing work in Erlang? It is by setting a token on the first process that starts a trace, and then propagating this token through Erlang messaging and other means by documentation, but I don't know what other means in this case. The usage is still straightforward, and the performance of this is usually negligible. You start a tracer process that will collect the information, again, like we did with DBG. You set some configuration flags. You set your tracer process as the system tracer in all of the nodes. Again, this works by setting something in all of the nodes and then collecting the result. You let the system make some noise, and then you stop the trace and get information. So the context here is we have another way to ask for our Fibonacci number. You ask Impero Frederick II, who hosted a mathematician called John of Palermo, who proposed problem to Leonardo Bonacci, aka Fibonacci. But those people just message themselves through different nodes, not on the same node this time. So let's see what is happening with sequential tracing. We fall back on the same take. The code is not important here. It's pretty messy. I'm just cutting down a lot of live book messaging just for the sake of clarity. The code is pretty ugly, if you let me say this. But again, we have the module. We will load it on both nodes this time with the usual comprehension and the AIPC call to code load binary. And then we will, with an helper module, just set up the tracer on all the remote nodes. So we start the tracer, we set some token like trace the sends, trace the receives, use a strict monotonic timestamp, set my tracer as the system tracer, and then we load on both the nodes. Here is live book crashing for I don't know which reason. We do the same thing on the local live book because it is from here that stuff will start, and we just call our Imperial Frederick II John server that is giving us the correct result. And let's see how it did it. So let's collect the trace, again, using a Gen server call to the remote traces. We have a big number of traces. I have 4 minutes left, sorry for that. And then again, not a super nice code. It just loots something from the local sequential tracer that ships with livebook and tries to get a sense of what is happening between the nodes. You see a lot of useless code. We have our module, and we format it in a mermaid-friendly format. In this case, I did a mess with timestamps, and you see the order of the messages is not correct, but we can tune it a little and get the correct result, I promise. So this was like what I wanted to show about the demo. We already went to our live book. The takeaways I want that we get from this is that Livebook can be useful also as a graphical tool for debugging purposes. That is a non-trivial application, maybe because we have a versionable tool. It is really more handy than copy-pasting stuff in the shell and then exiting because we forgot a parenthesis or stuff like that. It is a repeatable, it is a graphical, it is a reachable tool. But also I wanted to underline that debugging live system is a fun activity. It is, but it is complex. It will break things. It will break the immutable software rule. It will poke in production. It will throw you in a black hole of despair while you're trying to understand what is happening into your system. But still, OTP gives us, and Livebook gives us a lot of tools to address those kind of happenings. These things, in my opinion, can save your business, and sometimes, depending on the mission criticality of your application, even more than that. The code is available, or ugly but available. The gotchas are listed. I hope everything was clear because I have to be pretty fast. I didn't want to cut any content, so really sorry for that. I am available to any question even later. If I can answer, I will probably not be able to answer, but thank you. And again, thank you again for being here today, and thank you for Elixir Conf, sorry.
Thank you, Luca. I think we have time for a few questions, a couple of questions. This is so huge, yeah, back there.
Hey, first of all, thank you so much for the talk. That was awesome. I just had a question, or I guess kind of a comment kind of question type of thing. Is like, we saw this, and this is obviously, you had to do kind of a lot of things just to trace your functions as you were going through them, and especially distributed things and everything else. Do you think there's room for some sort of wrapper or library to improve the developer experience? Because this seems like a lot of, as you said, dark hole of despair in order to just trace through your application. I feel like there must be something more that we can do there, no?
Yeah, honestly, some other libraries exist, but they usually already covered in blog posts and whatever. I don't remember the name at the moment because I'm kind of excited, but I will write them later. So some wrapper already exists, but of course, it is another of the things that I wanted to show, that you just can write your own as a test, as a like a way to debug your things, and then understand if there is a room to stabilize them, to give them a form, and give them the dignity of a library. And in my opinion, there is a lot of space here. Yeah. So thank you for the question, because I think it's important.
We have one
I
more.
hope it answered to the question. Okay, sorry.
Cool. Yeah, one more here.
Well, first, thanks. It was amazing, nice journey. But I was wondering if things wouldn't be easier if you installed like the Kino and all the other libraries like in the production cluster just in case, and then use the live book to connect like as the remote, like instead of like the mix one connected, like the connected mode to the server.
Yeah, of course, having already the tools is good. But sometimes you just didn't know they exist, for example, in this case, or you didn't just wanted to add more complexity or more space to your program. That's the case that I wanted to address. But of course, if there is something that you already know in advance that you will need, in my opinion, it can be okay to just add it to your system. For example, not exactly the case, but I had to add XML to the application in this case. It wasn't enabled by default. I just took a choice, of course, by convenience, for my convenience today, but it is a little example of this. Yeah, you decide what ships with your application, and that's, of course, something that you can do.
Thank you.
Hope this answers.
Thank you for the talk. Can you share your experience with debugging like in real life? How did that go? What the problem was?
Yeah, the first problem that spawned this talk in my mind was like an n+1 query. Or not exactly an n+1, but pretty similar. It was both n+1 and a slow query. So we were really trying to understand why the execution flow of the program it was arriving there, but we couldn't replicate it. We had the test, we had really a lot of tests in that application, a legacy one, of course, but we couldn't understand. So we just took the staging environment, in this case, not exactly production, with some data from production and tried to debug the real things that were happening, because we just couldn't replicate on our machine in the test CE. So that was the problem that spawned the idea. And we just did it. I just did the flame graph without the live the smart cell. I loaded the library. I tried once one flow, another flow, spawning stuff from the UI, a lot of things, and then we tried to understand what was happening. I don't think it was what enabled us to resolve that specific problem, but I saw some power there.
So let's give a big round of applause to Luca, and thank you.